Alright, so this is exercise 7, and it says block A has mass 3 kilograms and block B has mass of 6 kilograms, right? Right here in the image. It says the blocks are forced together, compressing a spring S between them. Then the system is released from rest on a level, frictionless surface. The spring, which has negligible mass, is not fastened to either block and drops to the surface after it has expanded. Block B acquires a speed of 1 meters per second, and it says the final speed of block A and it probably says like to find the final speed of block A and the amount of potential energy that was stored in compressed spring is. Alright, so it's asking for VA and U. Right? VA, U. We see here that, well, apparently in the exercise, VA have different numbers. So all we have to do is find VA, and we're done with the exercise. I'm not gonna do this part because it's not necessary. So the principle here is that P1 is equal to P final, right? P initial is equal to P final. P initial though is 0, right? P initial is 0. Momentum, the initial momentum is 0. So then we left with final momentum, which is it's gonna be 0 equals to MA VA, right? Plus MB VB, right? We're dealing with block A and block B. So we separate them. MA VA is equal to the opposite of MB VB, right? The negative. So if we isolate the VA, which is what we want to find, MA goes dividing, right? MA1, MA, so MA goes dividing. And then we're left with VA equals minus MB times VB divided by MA right here. And if we plug in the numbers, block B is equal to 6. So 6, block A is equal to 3 kilograms. And then the speed is equal to 1 right here. 1 ms right here. So 6 divided by 3 is equal to 2. And since that's negative, that's going to be minus 2. So we found VA. So the correct answer is B in this case. And then we don't have to find the U because B is the only answer with a -2 here. So these exercises solved.